Welcome.
Thank you.
We really appreciate you guys taking time and excited to learn from you and also share a little bit about XSilicon. What's funny is in a previous conversation, I thought about it, and when I heard your story, it's almost like the start of a joke. A chip guy and a medical doctor get together at a conference. They walk into a bar.
That's exactly what it is. That's basically we do that every day as we're going into the offices.
Can you tell us a little bit about how you guys met and the start of XSilicon?
Well, I think I'll let Atif start because he was the one that really started the whole venture, and then I can talk about what me coming in. So
you know, in 2019, I have a company called Pixilica. And we're building small circuit boards for engineering students to basically learn about RISC-V. You know, I learned about RISC-V through a business partner of mine who said this is an up-and-coming processor architecture. We should look at it and see if it would help us to have a play in this. So I started learning about RISC-V, and one of the things I realized was that it's a microcontroller, but it has no graphics-related functionality to be able to deploy this in places like, you know, smart displays or cell phones or watches or PCs or anything else. So I basically invented an ISA for it. I defined a set of instructions for doing graphics, and I presented that in 2019, and you know, as just a open forum. And we had, you know, we thought we'd have a few stragglers coming in and sort of understanding what we're doing. Normally, we packed the house. We had 20 people waiting in line to get in. Every single company, AMD, Intel, ARM, NVIDIA, Qualcomm, they were all represented. Engineers from all those companies came to see what we were doing. And literally about 2-3 weeks later, one of my colleagues, John Petty, who's a very world-renowned analyst in graphics, I explained to him what happened, so he took that concept, he published it on his own website as an article, and I helped him write it. A year later, EE Times took that article and republished it on the EE Times website. Oh, wow. Within 2 weeks, it went viral. We had translations into 8 languages. Every single news site, like from Tom's Hardware to Hardware Lux, all these, you know, big news sites all over the world carried that article and referenced us. And so overnight, we were a sensation. Wow. So then engineers from companies like Broadcom, Intel, and Esperanto came to me and said, hey, we want to help you build this thing.
I had really been looking for something new. You know, I came from ATI, AMD, and then Qualcomm, right? And a couple successful startups before that, sold to TI and sold to Qualcomm. So, but I was kind of looking for something new, right? And my specialty is graphics and multimedia and those areas for use cases. And certainly, you know, we brought that to set-top boxes back, you know, in 2000 on channel. And then we went into mobile, right? And I was at Qualcomm for a number of years, kind of moving all these different types of use cases, workloads into cell phones, right? Okay. And lots of it was video, audio, imaging, those types of things. But really graphics is my background. So when we came in, I've been looking at RISC-V. So this is where it kind of worked out so perfectly, right? Because my family's from Northern California. And so we go into San Francisco every year. And we go into Union Square, right? And stay at a hotel there. And it's just like a family thing we do every year before Christmas. So that year, pandemic had just started. We started getting a bit out of the pandemic. Yeah. And I was sitting there, and there was a builders conference. So one of the first conferences that actually started in San Francisco coming in. It was at Moscone Center. And I said, well, I'm going to go down there and see what's going on. So I walked in the door, and here I think it's just going to be, you know, really cool. I'm going to get very geeky, right, with all the stuff that's there. And then I saw there was a RISC-V conference that was there to sit. That was when they had that summit. Right. So I walked in the door, and all of a sudden I'm looking, and there's all these companies I know. Imagination Technologies is there. Yeah. The MIPS guys are there. There's lots of different people. I'm like, what is going on here, right? Because I hadn't been following it that close. And so and behold, there's a guy that is part of our founding group that was there. That we were very close at Qualcomm. And he said, hey, you got to go to dinner with me. And we went to dinner, and there was Atif. So that's kind of how it combined together. Yeah. And he said, you know what, Dan, you got to commercialize this.
You know what? Let's take a step back. And what qualifies you guys to talk about graphics chips? And tell us a little bit about your background, because both of you have very unique backgrounds.
On my side, I mean, I really, you know, I was brought up in startups, you know. Obviously, I came out of doing Java. I was one of the first Java architects, and I really wanted to do PJava. So, and that was something for personal Java, and it was a big thing at Sun Microsystems, and they kind of didn't want to, they just didn't pursue that portion of their business. They certainly did the JCP, and they were very successful in the Java community by doing it, right? But they didn't take the plunge of really putting together a complete system. And I said to myself, it was a partner and I said, we're going to put embedded Linux on we're going to shrink down Linux and we're going to put it on a MIPS processor. Well, we need to figure out how we're going to do graphics, right? Because we had to have UI. Yeah. So we used a regular Netscape Navigator browser, right? With SSL security on it. And put that on a MIPS processor, right? That's where my graphics kind of background started. And before that, we used to just play a lot of games, right? And doing things, but getting all that on platforms was really where it started. And then it just started kind of continuing to go, right? Now we put Java in place. Now we had to put Java in place for cell phones, right? We need a standard around that. So I was very heavily involved with that with a company called RedWave with Sun Microsystems. And we sold that to Qualcomm. And then at Qualcomm, I became the guy that ran graphics at Qualcomm. So we started graphics at Qualcomm there under myself. And then we actually defined the first OpenGLES spec at Qualcomm in a room together, and we decided we have to go OpenGL. We have to move away from proprietary to OpenGL. And then at that point in time, we decided to put IP into our chips. And of course, we went and talked to all the different graphics providers, including NVIDIA and ATI and Imagination and others. We ended up picking ATI for various different reasons. And then after that, I left Qualcomm. I needed to take a little break and time off. And I decided to stay at home for my first child. And within 6 months, my ex-wife was like, go back to work. Like, this is not working. So I went to ATI. And I went to ATI and I went and worked with their 3D roadmap and IP roadmap. And then also their SoC, defined their SoC. So I was there for 7 years. Moving these graphics into all different types of devices and mainly mobile phones. Wow. And then went through. And then we ended up selling that group back to Qualcomm. So it's kind of interesting, how it happens. But if you look at it, that's graphics for 15 years, and 20 years.
I've been doing graphics since I was 16 years old. I started programming 3D rasterizers on an Apple II 6502 assembly language, self-taught. Reading books, the graphics textbooks at that time, Newman and Sproul and all the big textbooks, and implementing those algorithms in assembly language on a 6502. So I've seen the evolution of graphics processing units all the way from when they were just VGA cards to then, BitBlit devices to, things like the 3DFX cards. And I've seen the evolution of the architectures from the very beginning to what they are now. And what I'm finding is it's a rehash of old technology. So if you look at the NVIDIA or AMD architectures, they really are the old SGI reality engine type devices, just implemented on a chip and then replicated thousands of times. The architecture has stayed the same. The algorithms they implement have stayed the same. So what I wanted to do was to innovate in the architectural design of graphics so that now you're free. My tagline is free the pixel. So, so I've seen the evolution of these architectures since I was very young. And then now I know what the next gen needs to look like. There's going to be a blurring of the distinction between device and where the compute actually happens.
Yeah, we see federated compute. So that's how we see it, right? Instead of just looking at federated AI or federated software security, we kind of look at federated as the next generation for compute.
Imagine a $100 cell phone that never needs to be upgraded.
I've got 5 children, who are all entering cell phone age. So imagine I'll sign up for that. Exactly. You guys said you had something special to share because you guys know how passionate I am about democratization of AI. Yeah. And I want to actually double click on that AI subject for a minute. What do you see, Dan, as something happening in AI, an advancement in innovation that's going to happen in AI in the next couple of years that other people don't see?
I defer whenever I talk about this, right? I defer to my knowledge around devices, right? And coming from personal devices. I think that area is going to explode, right? I mean, if you look at guys like Qualcomm, for example, right, where they're redefining what's at the edge, right? That's going on. I think there's lots of different companies doing that, and I think before. We used to do a lot of this before it was even known as AI or ML, right? We were doing cognitive research on cell phones, right? To kind of learn what people were doing and doing those types of things. And we take that information out and then we'd use it, right, to make sure that we got things done right. We got the right requirements, those things. But now, the explosion of allowing for your device to become so personal to what you do in a very secure and feature-rich manner, I think in personal assistance, you're going to see things dramatically change for you as a day-to-day individual.
Are you talking about the personal assistants like Alexa and Siri, et cetera?
Yeah.
Are you talking even further
I'm talking
advanced,
further
like
advanced.
robots?
Absolutely. Well, yeah, that'll be part of it. But I think what it's going to come down to is instead of you being part of some other network, you are the network, right?
Okay.
You know, everything's going to surround how your personal attention and what you're doing every day, and really melding to. I mean, your cell phone is going to potentially even start knowing what you need to do on a daily basis without you even thinking about what you do. I mean, a lot of times, right, when we were back in the day, we were looking at different types of users. And you would be surprised how many things you do every single day that you're just doing subconsciously, that you do every day. Well, how about being able to enhance those things, right, even further? And it's really going to make you more efficient. And I think that's what everybody needs to understand, right? It's about really doing that. So I think that if you talk about the types of use cases that are going to happen, you can just think about your scheduling or this, and those are things that are there. But when you start thinking about how it's really going to dynamically change, ahead of time, right? Where, it's my wife's, a birthday, and I just decided that she loves to have that cake.
Yeah.
That's there, right? She loves this Italian cake, right? For my girlfriend. So it's like it's already going to be ordered.
Yeah.
But before it was being done in the cloud somewhere and something else. Now it's your personal cloud.
Okay.
That's going to happen. And I think when you start looking, then you start peeling the onion of what it takes to do that. Then it starts getting big.
Yeah.
Right? Because now you have to have it on the edge.
Yep.
You can't do it someplace else. It's not about the cloud anymore. It's about your personal space and what you're doing within your own personal cloud.
And that has to happen from a security perspective as well. Atif,
Yeah.
what about you? What do you see happening that no one else sees or very few do?
I think there's a lot of emphasis right now on developing hardware for AI. I think a lot of chip companies are in the market for doing that. There's going to be a consolidation.
Yeah.
The worry I have is the algorithms are changing too fast for the hardware guys to keep up. And as these algorithms change, the hardware that's being built is going to become obsolete very fast. So we take the opposite approach. We say, let's do software first, put these algorithms into software, accelerate them when they're to the point where they're not going to change much more.
Yeah.
There's going to be an asymptote for when that happens. And when that point is reached, that's when the hardware guys should come in and accelerate those algorithms. Right now, for example, 4 bits for inference is what's the state of the art. Right now, Microsoft has a paper that says 1 bit is enough for LLMs. So all the 4-bit guys now, their hardware is going to become obsolete. Because if you can do it in 1 bit, why are you spending time doing it in 4 bits? So I think and your new algorithms like spiking neural networks that Intel is kind of working on, these other algorithms are going to come down the pipe. So we need to have an architecture that's flexible enough to accommodate new algorithms dynamically without having to respin your hardware.
It's almost like try before you buy.
The other aspect I see is that we're going to, just like we repurpose GPUs to do other workloads, we're going to repurpose the AI processors to do other workloads.
Yeah.
Like I have defined an entire an entire set of algorithms to do graphics on neural network processors right now. I have it laid out as to how you do rendering on a neural network processor. So that means that instead of doing these workloads on GPUs, you'll be able to do those workloads on NPUs.
On NPUs.
And that's going to be a very interesting play because those NPUs were not designed to do graphics. But people don't realize graphics is all matrix math. So if you can redo matrix math on an NPU, you can use all that power.
And I'm curious too, one thing we haven't even talked about yet is the uniqueness of your background. So you're a trained medical doctor.
Yes. So I can tell you my history in, succinctly. So we have 4 kids in the family. My mother's a physician and she wanted all of her kids to go into medicine. So me being the oldest, it was her dream for me to be a doctor, so I became a doctor. I did very well.
What kind of doctor? I'm
an internal medicine doctor.
Okay.
But I did a fellowship after internal medicine in medical informatics. And so I became a health IT sort of specialist. And I did a lot of work. I had $25 million in grant support as an academic physician. I'm a professor at Indiana University School of Medicine. Yeah. So I've been there for 30 years. $25 million in grant support, 35 papers, a book chapter. I served on President Bush's Advisory Council for Electronic Medical Records, helped build the National Health IT website at HRQ, did a lot of consulting work, traveled all over the world giving talks. Left that in 2010 to be an entrepreneur. And now I have a lot of companies doing very advanced stuff, including XSilicon. So I never really wanted to be a doctor. I wanted to be an engineer. My passion was computer graphics. So my brother became the engineer. So during the summer times when he came home from school, from his college, this was back in the 80s when we didn't have the web.
Yeah.
I used to read his textbooks.
Yeah, this is a great
I read his textbooks on computer architecture, on hardware design, programming, all that stuff, and taught myself everything. And being in the throes of graphics, you know, going to all the conferences. I've been to every SIGGRAPH conference since 1989. So I'm a pioneer in that field. You know, I know all the people.
Yeah, and birds of a feather papers. I mean, all the different types he's done.
I'm self-taught,
phenomenal.
and I know intimately computer architecture. Like, you know, what's wrong with it? How do you fix it? There are severe problems with GPUs right now, and we can fix it with our architecture.
Do you think that your training as a medical doctor, but also the fact that you don't have the formal training, the same formal training, has actually helped you?
Tremendously.
Yeah.
It helps me think out of the box.
Yeah.
I'm not limited to the, you know, engineers solve problems that exist.
Yeah.
I invent things to solve problems that don't exist yet. I create markets for technology that doesn't exist yet. The markets don't exist yet.
That in and of itself is opposed to what any MBA student would tell you is you've got or any engineering student is you've got to solve a problem that exists.
Yeah, and actually they're pretty predefined too, right? And that's the difference.
That's the mark of an entrepreneur.
Yeah.
Like Steve Jobs when he built the iPhone. Did you need another phone? No. But he invented something with a power to do something that didn't exist before.
Yeah.
It was the App Store that sold the phone, not the phone.
Yeah.
But the things you could do with that phone, with that device in your hand, were so profound that it changed the world.
So if we're to fast forward then, we're to go past the conference and then CES 4 years later.
Yeah.
Why? So XSilicon is coming out of stealth.
Yeah, it's
watch out. Why now? Why is now the time?
So it's been an interesting ride. I mean, with every startup, this is my fourth. And I think everyone is so different, right? Here, you know, we came in with a bunch of brilliant minds. We spent so much time. We spent over a year, almost a year, right? It was like 8 months just doing architecture, just going and talking to all the different big guys, bringing in guys that we knew that were retired, right? Looking at our architecture that were, you know, from the NVIDIAs, from AMD, from others, and really having these people, you know, think out of the box. Right? What can we do right? What can we do wrong? And so what we did is, as we were going through this, now we built up so much ourselves because we're really kind of self-funded by ourselves. Mm-hmm. We've taken some money, but really it's us doing the work. So now we've got all this great input. So now we actually have customers coming down the line. So really now, you know, people have bought into what we're doing, right? And we have our software implementation. Before, we really didn't think we were going to do a software implementation. It was really for our own benefit, right, internally. Yeah. And then as we started going out, we were saying, wow, this architecture works so well in software. And it was so performant just on standardized RISC-V and ARM platforms. So we're like, wait a second. And we started talking to customers and they said, well, we want that now. Can we get that now, right? We have these platforms. We don't care about you having the hardware assist yet. We want to get our platforms out there.
One of the things is that there's going to be a big push into Android cell phones running on RISC-V.
That's another part too.
That allows us to create a device for those phones that doesn't exist yet.
Yeah.
So I think to capture that market, we need to be out of stealth and talking to our customers and
that was kind of
getting Android ported to the RISC-V platform and, you know, our ISA extensions accepted and running Vulkan and all those things which we're doing. So this is the best time to be out of the stealth and penetrate that market early on.
So really customers one part, and then the right timing for the rest of the ecosystem to come together, right? We had to have both, right? And so we're seeing that kind of converging, and that's one of the reasons we think it's the right time for us to come out.
Well, and speaking of ecosystem, a core belief of mine in this space is that you cannot be a software or hardware company and survive. I think that totally the winners need to provide both. You guys have taken the software first approach,
sure,
but you're also going to be providing hardware.
Absolutely. Yeah. I mean,
let me explain that.
That's a big part for it.
The future of technology and compute is software-defined hardware. So software has to define the way hardware works. Because right now you can build hardware and your software may run inefficiently on it, or maybe designed for one application and not others, which is what we're seeing with GPUs. What's going to happen in the future is software and data path pipelines that are completely configurable from scratch. They'll be dynamically configurable as your software gets written, so the hardware adapts to the software.
Yeah.
That's the future.
That's the key.
So that's why you have to be both.
Yeah.
You have to be a hardware and software company. So you have a hardware platform that's malleable with the software that is going to come down the pipe. So our architecture is open in that sense that we have, a unified instruction decoder, unified data path pipeline. Think of it as a large superscalar design.
Yeah.
So you have multiple units working in concert, each taking different types of data elements and processing them in parallel. Now think about scaling that across a chip. So one core could be running, some rasterizer algorithms, another one ray tracing, another one AI, another one physics. They're all working in concert. You're not, unlike GPUs that run only one workload at a time, this can run multiple workloads at a time and composite the results. So what happens is you get efficiency, you get reduction in silicon area, you get reduction in power. And so for small, tight devices, that are embedded devices, mobile devices, this is a very good architecture because now you can multitask, but save power and area and cost. And so that's our goal.
Have you guys gotten pushback on the from the investment community in particular on having the open ISA?
So it's an open ISA. The difference is it's an open ISA, not open hardware.
Yeah.
Okay.
The way you implement the ISA is protected.
It's big important.
There's many ways to implement a particular instruction in an architecture.
Okay.
However, the instruction itself and the register files need to be open so you can program that hardware. How that translates into actual execution is proprietary IP.
Yeah.
So by not exposing the proprietary IP, the user might think it's being done one way, but we may be doing it in a completely different way under the hood. So that protects us. But the value of that open ISA is that now you can actually get down to the metal, and you can do things very efficiently that you weren't able to do before. Like for example, to run Vulkan, it takes 4 or 5 pages of code to draw a triangle. We can do it in 5 lines.
Yeah, and also one of the things for us too is, we're more CPU bound, if you want to call it from a development perspective, right, comparative to GPU bound. So we don't have to move everything into shaders, these complicated shaders, everything else.
Yeah.
You really just give us C code, and we're running it. Right?
The concept of shaders goes away.
Yeah,
so you don't need shaders because it's a single line of code.
And single instruction set too.
We don't need to even support something like CUDA because everything runs in C on the hardware.
What are the headwinds that you guys are that you see XSilicon coming up against as you come out of stealth?
Yeah, so I think there's there's always things that keep me up at night a little bit, right? If you want to ask that question, and I think it's really we talked about this before, right? It's the ecosystem. I think that one of the things I think with this new kind of explosion of what's going on with AI and ML and what we see graphics now moving into utilizing a lot of the techniques that you utilize for matrix math and we're very involved with vector and all these different types of pieces and coming together is how is the ecosystem going to react to these new architectures, because it takes a lot of us, right? I mean, certainly you could be at NVIDIA or you could be at some of the larger companies, right, and try to make all those pieces fit. But I think truly you're only going to see this happen in a very, very efficient way and see innovation by kind of the open market taking hold. And I think, for myself, I think the headwind that you're talking about is how quickly does the ecosystem enable more openness, right? And I think that's what it comes down to. And I think, even when you talk about, open AI guys and all the different aspects that are there, I think it comes down to, on the AI side, how are you enabling all these guys to build? As fast as we can enable these guys to build and have unique ideas for different models, different things that they're doing, the quicker all this is going to happen, right? And I think that there's right now it's kind of a flurry without having all the piping done correctly, right? And that's where I think that those building blocks, I guess I would say, need to be there.
We will support the standard APIs. We won't. We will have Vulkan. We'll have OpenGLES to support the legacy hardware and software that's there. We will support that.
Yeah.
But there will be an evolution towards more customized open source designs, where you don't necessarily need to go through a standard pipeline. You can do things efficiently on the hardware level that you don't have to do 5 pages of code in Vulkan to do. You'll be able to do it faster.
How are you guys solving memory?
So we have near memory and in memory processing.
Okay, I was gonna say,
so the first patent,
IMC,
the first patent is in memory processing.
Yeah, for RISC-V.
That's the future.
That's our first patent. It's around RISC-V, and initially it was for graphic workloads only, and now we have another one coming down the pipe that's allowing for AI and compute.
If you look at graphics, it's 80% memory access, 20% compute.
Yep.
So it makes no sense to put the memory outside the GPU, right? Absolutely. If it's inside a shader core, then it's
so now the configurations that customers want to see us in is they want to see us in kind of more of a big little type of configuration where we're almost running as a dual master.
You mentioned SiFive, you mentioned Ventana, you mentioned Andes, all companies that we believe in. Have they all converged at a similar time? Or tell us more about those partnerships.
Yeah, I think we're blessed to have those kinds of partners. I mean, if you really look at, and I think that's really, of course, we love the ARM system. We're working in the ARM ecosystem and others, past and x86. I think all those companies had these same type of uniting, right? But I think you look at the kind of the openness of RISC-V and these guys coming together. You see people working together that you would think would just be first competitors, right? And really, that's a breath of fresh air. But I think if you look at us, we have kind of targeted our partnerships, if you've noticed, based off of kind of our announcements that we've done, and you get a little bit of a glimpse of where we're going, right? And so you look at SiFive. SiFive, actually, we've been working on their platforms really from the beginning, right? We started on microchips. FPGA platform, right?
Yeah,
PolarFire. So certainly there, we got to give some props to the micro guys, and then also, of course, with SiFive. So their platforms we kind of knew, we kind of grew up with, right, with a lot of things we're doing, and then of course the Andes have some other technologies and other benefits that are going on there that we're working closely with them on. And then, of course, the Ventana guys, which we know a number of those guys. There's a couple of ex-Qualcomm guys that are there, so we're feel pretty comfortable. But I think that the Ventana one, everybody asks me, why Ventana, right? Because that's kind of an interesting type of relationship. That relationship, I think, is going to be extremely fruitful for us, either short term and long term. But really, it's to take care of this market that we're seeing, which is really this kind of CVM type of virtual system that we see, and so we needed to be with a partner that was on the high compute type of area and higher edge aspect, and I think you're going to hear some more coming out of that. So I have to kind of leave that one for the next time we come.
Okay.
But I think you're going to see some pretty interesting types of relationships and partnerships you're going to see out of that side of us. I think you're going to see some pretty interesting things coming out of this architecture in more of the high computing space, and so we can't leave it all out there today.
All right, well, we'll stay tuned for that.
We'll do the next one.
You mentioned a few times, I want to hover over this for a moment, all of us, and you mentioned earlier on, it's really the team plus you.
Yeah.
Can you tell us a little bit about the team you've assembled?
We have some of the top guys that really were involved with the ATI AMD transition, guys that certainly came from Qualcomm through that process, and also Qualcomm on the other side.
How big is the team now?
We're actually relatively small, right? We're under 20 people.
Okay.
But from our perspective, and that's one of the reasons we're coming out stealth, too, right? Because now we have customer activities that we have to really look to staff up for. But I think if you look at the executive side of this, and it's just a who's who of people that have come in the industry to do the exact same thing that we're doing. Just now it's the next gen, right? So that's kind of the way we look at it. So we were very lucky to kind of have these people come when they did. It was very easy, quite frankly. It's all about timing. Timing is everything.
People are looking to do a new GPU. If you look at the chatter online about the idea of a RISC-V open GPU, everyone is excited about it. So some of the team members are very excited. For example, we have people from people from Imagination, people from, who were part of the ATI, AMD, Qualcomm. Yes. They're all autonomous. You don't have to tell them what to do.
Yeah.
They already kind of know what the next step is, what to do, and what they need to do, and they work independently. So they're leaders in themselves. So we don't have to manage them. They get managed. They manage themselves, and they produce results. That's the advantage we have.
We're really challenging our people to come up with new and inventive ideas. I mean, just like you talked about, well, what's going on with memory? Well, we're already doing it because we already had patents in there. So we're challenging our people to be rock stars, right? But not rock stars to the extent, it's almost like when I went to ATI. So many brilliant people that were there, but they worked all in this kind of very mellow type of, united type of force of people going and doing it. And I think we have that culture internally.
Okay. Are you guys a fully distributed workforce?
Yeah, we are.
Okay.
We are. So we have people in Barcelona, we have people in the UK, we have people in Toronto, we have people in San Diego.
Turkey.
So in Turkey.
Some of the old ATI guys.
And now we've got a couple guys coming on from South Korea. Right?
South Korea.
Really?
Yeah.
How do you solve the age-old but very new problem of getting a distributed workforce that all work to be rock stars, that all work with that kind of discipline, with that kind of rigor, with that kind of passion?
Yeah, I mean, I think it's really interesting you say that because, in the beginning, a lot of us worked together. I mean, Atif and I had not, but we were kind of soul brothers, so it came out very quickly. But you look at a lot of us, we've been working together for so many years. You just trust it. It's like it's done, right? I mean, there's four, like I say in the company, there's 4 guys that can take my job today, right? I mean, that's the kind of talent we have.
People are really passionate about the idea.
Okay.
Yeah.
They're really sold on it. I mean, if you talk to any one of them, they're totally sold on it. And they want to be part of that future. Yeah. That's what drives them, I think.
And I think that's what we're looking for in new people that are coming. Because we're really, like I was trying to make the point of that we trust each other. We want people now that are coming in that, we have to have a good mix. You have to have a good mix of young and older and all these different things together to make things work, right? Mm-hmm. And I think, a big thing is passion he's talking about. Second thing is we want entrepreneurial type of people.
Yeah.
Right? We want people that are going to take on that, they're really almost like their own mini GMs. And, and I think that I learned this, as you say, you learn from every experience you've been in.
Yeah.
I learned this at Qualcomm.
Okay.
What a tremendous organization that they are in regards to allowing for each individual to own their own business. It's like owning their own business. Like when you're doing graphics, you own that business. Of course you have oversight and you have other people around you. But at the end of the day, you're owning that business, right? I mean, that's who you are. And I think that ownership stems from the management to, definition to engineering to this. It's all about accountability, right? But it's about being in this sense of really believing in what you're doing and picking entrepreneurial people that can do that. And I think that's, everybody says they're an entrepreneur. It's very difficult to be an entrepreneur.
Yeah.
Right? And I think we're trying to pick those people that want to work, they want to learn from each other, but they want to come up with their own ideas, but they really want to have their own ownership.
I did a LinkedIn post for the article that came out about us in, I think, Tom's Hardware or something. Mm-hmm. Right after that came out, I had more than 15,000 views of that article.
Yeah.
And literally hundreds of people reached out to me saying they want to work with us.
Yeah.
Sending me their resumes, sending me, and these are senior level people too, not just kids out of college.
Yeah.
Yeah.
These are senior level people that said, we want to work with you.
You guys both know this has been a hyper crowded space. Yeah. And what I'm excited about for you is that we've already seen the .com bust, I guess, of AI.
Yeah.
So much money was poured into it. So now you really do have to show something differentiated. So you guys are going after the first round of funding soon, right?
Yeah. I mean, we've been self-funded, so now it's time to put some people in the seats and go out and take care of customers' orders.
Talk to us a little bit about timeline of scaling the company.
I think once we have our first, funding event, we will be scaling pretty fast. I mean, 40, 50 engineers possibly, getting to a minimum viable product in hardware, one of the challenges we've had is this is such a different architecture, people don't understand it.
Yeah.
When you talk to a VC who's not tech savvy, they don't understand how this is going to work. Right. That's the question we
Strategics have
had.
to know it. That's why. Yeah.
They don't see the incredible, ease with which we can implement new algorithms on this architecture. And I think once they see that, that aha moment will happen, and then the floodgates will open.
Yeah.
Right now, we're still in that education process of telling people, hey, this is what we can do with our stuff that nobody else can do.
Yep.
And that's the sort of PR we need to do right now.
And I think strategics, as we talked about, are seeing that because we're already there talking to them.
Well, and there's two other things that were mentioned earlier that I think play in your favor, and one of them is being self-funded for as long as you have is incredibly wise. It's going to help you as you go out to the investment community because you've already put your money where your mouth is.
I mean, the risk.
Also, you have absorbed that first 4 years of the trudge. And also, though, you mentioned something that a lot of people don't realize is NVIDIA 10 years.
Yeah.
And so the investment community oftentimes can be impatient. And the return on investment needs to be 3 or 4 years, not 10 years. So you guys have absorbed a lot of that, which is incredibly wise. There's something you mentioned in a previous conversation we had that I think is important. When you're looking for an investor, what are the things you're looking for?
Yeah, I mean, I think that, I go back to the days when I first started my first startups, right? I mean, when we first did first on channel, we went to, it was another thing like that, right? It was a garage startup that we had and did one press release, and I don't think any legal guy would let me do what I talked about then, which was taking on Microsoft with Linux. So I'm surprised I'm still around. But really, that happened, and the press release came out, and it ended up that CNET wrote an article about it, and Brooks Carruthers, who was a staff writer at that point in time, right?
Wow.
And it flew, right? And I think that we had more VC guys that were there, right? Sand Hill, we were going up and down, just writing our own term sheet if we wanted it, right? But I think the difference was, and I'm not saying anything now. I mean, obviously the VC community is great and everything else, but at that point in time, I think you had a lot of kind of new guys coming into VC too, right? And they wanted to spend time. It just wasn't about what they were going to make next month, or what they had to tell their hedge funds, or what was going on in the rates of return, right? It was really guys that had been through a lot of it.
You had alluded to earlier, you're not just looking for money.
No, we're looking for strategic partners. We want people that are committed. I walk in the door to a lot of partners and I tell them, hey, I'm going to use your part. And they say, yeah, that's great. No, I'm going to use your part. We have to consummate some sort of relationship that allows for me to know that you care about me, right? And we care because you're a big company. You've got all these different things you've got to look at, and maybe there's times where they just say, no, Dan, I can't make that commitment.
Yeah.
We say no problem, right? And then we go on to what we need to do next. And so, but it's really important for us to have this kind of, and we're the same way. I mean, when we say we're going to do something, we're 100% in.
So in closing, if you were to have 2 sentences, 3 max.
This is always the tough one. You always read the last one, the toughest one.
To tell an investor that you already like, that you think is right for your business, why they should invest in XSilicon, what would you say?
Yeah, I mean, I think that really, I mean, as far as it's concerned, we are patterning, right, what's going on with next gen, and so your rate of return is going to be there, right? So you depending on where you are as an investor, you don't have to worry about not getting that, that whatever predetermined value you believe you're going to get, right? Because we're going to be here for a long time.
So I think what's differentiating about our architecture, what I would say are 2 lines. GPUs were designed for one purpose, gaming, and they're now being retrofitted to run algorithms that were never designed for. We are re-architecting the GPU from the scratch to run next-gen algorithms that have not yet been invented. Wow. That's my 2 lines.
Well, you guys have been awesome. The passion and the brilliance between the 2 of you is nothing short of remarkable. I'm humbled that you guys would spend some time and share with our community what you're doing. And I will say this in closing. two guys, a chip guy and a medical doctor, walk into a conference.
That's exactly what happened.
And change the world.
Yeah.
Yes.
Yeah.
Thank you guys.
You're very welcome.
We
Thank you so
appreciate
much
it.
for
Thank
having
you.
us.
Absolutely.
Take care. Thank you.
Take care. Very nice to meet you.
Awesome.
Thank you very much.